don't go believing anything I say. No, don't go believing me. No, don't listen to me, don't take any notice. Don't listen to anything that I say. Thank you.
Once we launch this little baby, they're gonna flip.
Okay, I think we're ready to go. So first of all, welcome everyone. We're honored to have you at our panel discussion here on what if everyone had their genome sequenced from birth. My name is Dr. Liz O'Day. I am the CEO and founder of a precision medicine company called Alaris Therapeutics. We do metabolomics and machine learning to figure out which drugs work for which patients and also which ones do not. I'm also the co-chair for the World Economic Forum's Biotechnology Council. I'm I'm thrilled and honored to moderate this panel today, and I'm also incredibly excited because this session is actually being live streamed right now on the forum website, so hi Mom. And we're also hoping to have some interaction, so we've set up, if people at home watching want to tweet me at lizard0126, I'll try to do my best to get your questions relayed to our panel.
Now people wonder about why, the whole conspiracy theory thing actually comes off so well. Well, it's just like that. User profile. Lizard 0126. Oh well, the lizard is because, well, it's called Liz. Or she might be a lizard, you never know. But the 0126, no matter which way you cut it, is 666. Ignore the 0 because 0 is nothing and the all in numerology. You don't count that. 1 and 2 is 3. 3 times 6, 18, 3 sixes. 12 and 6, 2 sixes, 1 6. 666. That's how it works. They even use it in Masonic stuff.
So before I bombard our panel, our incredibly illustrious panel with a series of questions, I actually want to start with the audience here. To get a quick sort of baseline temperature of the room, I'd like you to raise your hand if you think, starting tomorrow, all babies should have their genome sequenced. Okay, now raise your hand if you think they should not. Okay, so it's about half and half. Second question. Raise your hand if you think, in the future, the majority of babies will have their genome sequenced. Okay. For those at home, you can't tell, though, nearly the whole room's hands went up. And interestingly, I actually conducted an online survey just last night through sort of different social media chains where I asked those same questions. And the response was the same. For the first question, people were really mixed about whether this should happen tomorrow, but near 90% of the respondents believe that this will happen. So it's with this sort of futuristic certainty theme that I want to sort of try to unpack this issue with our panel. And what I'm going to try to do as your moderator to make this session informative, fun, and interactive. So we're going to make sure to save room for questions for you guys. So with that, I'm going to ask the panel to sort of introduce themselves. We'll just sort of go down the row here. Could you tell who you are, what you do, and actually where you live as well?
I'm Matt Hancock. I'm the UK Secretary of State for Health and Social Care, and I'm also the proud shareholder of...
No, he's not the proud shareholder. He doesn't own those shares. He doesn't have anything to do with them. His position in office holds the shares. They are state-owned. They're owned by us.
Genomics England, which is one of the most cutting-edge organisations for genome sequencing.
So there you go, a bit of misinformation for you, leading you to believe that he owns the shares. No, he doesn't.
In the world, and we in December hit the target of 100,000 whole genome sequenced.
Wow.
So in November 2018, 100,000 genomes were sequenced. how many did they actually say they wanted for testing for COVID in 2020?
And we have reiterated a new goal of reaching a million in the UK over the next 5 years.
Remember, they wanted to ramp up testing from however many hundreds or thousands per week to the number that he came up with, supposedly, of 100,000, which even Cummins said was beyond the capability at that point. So why did he actually do it? Well, it's because they wanted this million genome sequences, and what a time to go and get them. Because otherwise they'd have been looking at 5 to 10 years. How many do you reckon they've got up to now?
And the critical next phase will be to deliver that. And the critical next phase will be to deliver that.
So a critical next phase is delivering that. Critical next phase in what exactly? Well, now's the perfect time to go and grab it all, irrelevant of what's going on. Because if you've got an experimental trial drug on the market and you're looking at sequencing genomes, well, if you get a genome that's not been affected by anything, and then you get a genome that's been affected by something, what a lot of information you get for not a lot of input. And this is why, in the lessons learned, he mentioned about new DNA and new RNA.
And the critical next phase will be to deliver that within clinical settings, within clinical settings, within clinical settings, within clinical settings in a way that improves people's lives.
Now, isn't that strange? Within clinical settings that improves people's lives. Really? It's
Awesome.
So I'm Jay Flatley. I was the CEO of Illumina, based in San Diego for 17 years. As of the summer of 2016, became executive chairman, and we supply the tools for doing microarrays and DNA sequencing, and have been very delighted to work with GEL.
GEL. Genomics England. Well, at least you'd allude to that, maybe. Or is it hydrogel? So you can't discount these things when they just mention it off the cuff.
I attended there because I was given information that the PCR tests are contaminated, and they contain a substance called ethylene oxide, which is a dangerous gas, lithium, which is a dangerous substance unless it's prescribed by a doctor, and hydrogel.
A research team at Cornell University has made a new metamaterial, a gel made entirely from DNA and water. It can go from having a specific shape to being puddle-like and back again. The hydrogel, as the scientists call it, remembers its original shape when it is submerged in water. It only loses form outside of water. These gels are the softest ever made, the Cornell team says. Why is that? Inside the materials are extraordinarily long single strands of DNA, 140,000 DNA bases long. Some of them hydrogen bond to one another, but they mostly entangle, forming bird's nest-like structures that can be viewed under an electron microscope. It's these entanglements that keep the gel together and give it its consistency. The gels are so soft, in fact, the Cornell researchers think that they collapse outside of water because of gravity. Underwater, though, buoyancy balances out that gravity, allowing them to maintain their shape. Like the robot assassin T-1000 in the movie Terminator 2, the researchers think the hydrogel might one day flow through a tight space and retake its original shape on the other side. But in the meantime, They've got their sights set on using the unusual materials in drug delivery and electrical circuits.
To complete the 100,000 genome project.
I said we did the sequence. Actually, Jay did.
Yeah. So, actually, yeah.
And you paid for it. So.
Yeah. That's not an unimportant part, yeah.
Awkward silence and misleading people again.
I'm Jody Halpern. I'm UC Berkeley's professor of bioethics, and I also work in tech ethics. And relevant to the panel today, I'm a psychiatrist as well as a philosopher, and I have a big study that I'm running on how people's attitudes about gene editing, somatic cell gene editing, are transmitted from scientists to physicians to potential participants in phase 1 trials. So I look at how emotions influence people's health decisions.
Good morning. My name is Stéphane Bancel. I live in Boston, as you can tell from my accent. I'm the CEO of Moderna, which is a clinical stage biotech company. We are working to make a new class of medicine using messenger RNA. So the idea is to inject messenger RNA in humans, which we are doing as we speak.
So from clinical trials to global trials.
So that you make your own protein to heal yourself. I used to be in clinical diagnostic, running a diagnostic company called bioMérieux, and I'm on the board also of QIAGEN, the diagnostic company.
Okay, great. So we've got some key experts in all the different areas that this topic touches. But before we get started, I'd actually like to set a foundational principles and sort of a set of definitions. And Jay, I'm going to turn to you to kind of help us understand this. So if I wanted to get my genome sequenced, how would I do it? What types of sequencing options are available? And so how do they kind of all work?
Sure. I mean, the typical sample that's used for sequencing is a blood draw. It can be done in other ways. So any cell that is left behind, we can sequence. So we could sequence my DNA off the glass of water that I just took a sip from. But it would be, if you use saliva, it's a little more contaminated.
So there you have it, right off the bat. If you're not doing a blood test, all of these tests that they're running through PCR, because they're running off saliva, are contaminated. Period. They don't mean squat.
So the sequencing is a bit harder to get as good a data set out of that as you would out of blood, because that's a pure sample. Sequencing generally is thought about in 3 different categories. So there's whole genome sequencing, which is sequencing the entire genome of 3 billion bases, or 6 billion if you include the diploid version of the genome, of course. There's targeted sequencing, where you look at specific spots in the genome, but you're sequencing long stretches of the letters, A, C's, T's, and G's, and that can be, targeted 5 genes for a particular panel or 100 genes for a different panel. And then there's a third category called exome sequencing, where you sequence all the genes, and that number's moved around over the last decade in terms of how many genes there are. Current estimate is about 22,000 genes, and that's generally referred to as all exome sequencing. There's also a lot of confusion about the difference between genotyping and sequencing, and sometimes people use those words interchangeably. Genotyping, at least at a large scale, is done typically on microarrays. And when you're genotyping, you're looking at single spots in the genome that are somehow important, whether they're medically relevant or important for ancestry, for example. And so the consumer companies like 23andMe, Ancestry.com use microarray genotyping to do their consumer work. Helix, which is our consumer spin-off, uses all exome sequencing. And in the case, for example, with GEL, we did entire genome sequencing.
That's great. So I think one of the ways I think about it is that there's levels of going deeper and deeper into the genome. That sort of genotyping is sort of a high level. Do you have one of these potential SNPs, is what they're called, single nucleotide polymorphisms, particular genetic mutations, and then you can go drilling down all the way to whole genome sequencing, which is what is the 6 billion base pair code that makes J Flatley, you know?
That's right. And of course, in genotyping, you have to know what you're looking for in advance, so it's not hypothesis-free where whole genome sequencing is, because you have everything. In that case, you don't need to know what you're looking for in advance.
So with this understanding, I actually want to ask the same question to everybody on the panel. So sequencing exists, either genotyping like we've just talked about, or whole genome sequencing. I was wondering if each of you could just tell us if you have done any type of sequencing, which one, and why or why not, and what did it tell you, or what did you get the expectation that you thought you would?
Well, I didn't know you were going to ask this question, but
start at the other end, maybe.
But for Christmas,
yeah,
my brother bought me a 23andMe kit.
Okay.
And he's actually my half brother, making it even more interesting. And it's sitting in my kitchen. And my wife and I are debating whether to do it or not.
I'm having the same dilemma.
So I'm going to work out my answer to that by listening to the debate and the ethics of it. So this is a live question in the Hancock household.
Okay, great.
I wonder if he's done it yet. Or is it still sat in his kitchen? I mean, he's eager for everybody else to have it done, isn't he? I mean, he wants everybody tested. It's all about the genomic sequencing now, isn't it? Has he had it done yet? Or has he just had the PCR test?
Awesome. Jay?
Yeah, I guess you could probably infer that I've done every possible combination of these things that you could imagine. So I've been genotyped through all of the consumer businesses, sequenced my exome through Helix, and I actually had my whole genome sequenced in 2009 when we began our consumer sequencing program, and actually put it in the public domain. So my genome's been out in the on the internet since 2009. In terms of what I discovered, one thing that was quite interesting was that I have the most important variant for something called malignant hypothermia. And this is a condition where people die suddenly under anesthesia, having nothing to do with the surgery itself. Wow. And it's one of those kind of remarkable coincidences that being in that business, here's a condition that virtually no one knows whether they have it or not, but it's often catastrophic when it comes in the middle of a surgery.
Wow. See, so you can fully appreciate the whole genomic sequencing, tell you if there's something seriously wrong with you, even prevent certain things from happening that might end up terminating your life. But it's the way they're going about it at this moment in time, because it's not just for the sake of doing it. There's a lot of financial gain in this, and you're not gaining anything from it. It's going to cost you, some of you even your life.
Jody?
No.
And reasons why, maybe?
I won't take time with it.
Okay, we'll follow back on that. Stefan?
So I've done it a long time ago by a company that actually went bankrupt. I don't even remember the name of the company. Maybe you might remember, Jay, in Palo Alto. It was genotyping, maybe 10 years ago. But my wife has done 23andMe. So we can talk about that later. There's a lot of lessons from that.
Well, actually, Stefan, I'm going to put you back on the spot because I know we've talked about this, that in 23andMe and other things, they identify like risk factors. So whether genetics, and maybe Stefan, you can kind of take this over to me, what does genetics actually tell you, and how does that translate to what will happen in your real life?
So I want to try to oversimplify it, and which is going to be tough because some people in the room know more about biology than I do.
Yep.
So I don't want to look silly to them, but some people in the room, I think, don't know much about biology, so I'm going to try to find the right balance, which is going to be pretty bad. So first, there's a big difference between the genome and the proteome, which is what genes you have and which genes are expressed and becoming proteins.
The metabolome.
Yes, and we can go on with ohms. And then there are some diseases that are, from a genetic standpoint, pretty straightforward. Because there are, let's say, rare genetic disease, cystic fibrosis is very well known. You can get a genome, you get a mutation, you got both bad genes from mom and dad, then you have a disease. And then there's some diseases that we don't understand at all. I mean, just take Alzheimer as an example. I mean, we have a lot of ideas or hypotheses of what is happening with Alzheimer. But if you ask scientists who spend their life working hard to try to get forward with that disease, there's so much we don't understand. And then we should never forget that biology is systems, and a lot of systems, the immune systems, there are a lot of systems in biology, and there are a lot of pathways and feedback loops. And so sometime with a new scientific breakthrough that could happen today on a gene X, then it just changes how we think about the whole system. Mm-hmm. And so that's why I think it's difficult where science is today, which is there are some diseases that you can know right away, yes, the disease is going to be expressed, is going to be an issue. And there are other things where you can, I would say, worry yourself. where you don't really know if it's going to transform into disease down the road.
Perfect. Yeah, no, that's I think an important part, that I think genomics tells you what could happen, and that's an important and powerful what could happen, but it doesn't always tell you what will happen.
Now you can go and watch the original thing yourself and you can listen to what she actually says, but for what I'm getting at, there's nothing here that she actually says that's relevant to what I'm pointing out.
So the main thing as a psychiatrist to conclude is that one thing we do know affects the long-term health of a baby, and we have really good data on this, is maternal anxiety. And I want to say, I wish I could say more about paternal, but that's the studies that we really have, is on when mothers are anxious about the baby's health. It has for the first 5 years of life, it transmits a kind of, there's a lot of interesting biology of how this happens, but it's not just genetic.
Yeah.
So I hope people here know that you can actually have a psychosocial environment in the first 5 years of life that can affect your biology long term. And there's a lot of rigorous research. And so that will affect your temperament, your immunologic risk, and other risks long term.
So kids right now are being affected anywhere up to 5 years old just by the anxiety of the mother, by what's going on all around them. And the government say, oh, they've got behavioural psychologists and things looking at things. Yeah, what they're doing? Sat there with a magnifying glass, doing next to nothing, because they're not taking care of people's mental health. That's for damn sure. Not with all this bullshit that's going on. Ain't not one damn thing being done.
So without counseling, we make parents anxious because they know about something that they can't do anything about.
Yeah, or they don't know the full story about, and I think
or what they can do.
Yeah. So I think that's a really important point, and lets me transition over to you, is, and I don't know the state of play in the UK, but in the US, I think there's something obscenely low, like 3,000 genetic counselors available. So
yeah, it's terrible.
As more and more of this data is being generated, there's fewer and fewer people that can help make sense of that. And that, I think, creates a burden for people to, just know what to do with this data. So, in the UK, I don't know if you are addressing this sort of genetic counseling problem, and how you're trying to both think about integrating this into your system.
Yes, well, we are. It's an important part of the clinical intervention.
Debt services dwarfs hardware. Now, you really want to talk to me about stock prices?
The shareholders won't be happy.
It's not our job to make them happy. It's our job to make them money.
Yeah.
But it's early days. There is some early evidence of very significant positive impact when a baby is already ill. So to the point of selection, as opposed to looking at the population as a whole. There's a study based on some work at Cambridge University hospitals in Cambridge, England, that the whole genome sequencing of ill babies changed the clinical treatment in 75% of cases.
Yeah.
So this is a big demonstration of the positive impact of genome sequencing where the baby is ill. Yes. And so we announced earlier this month that in future in the UK we're going to sequence the genomes of all children with cancer.
Can't say I've heard of it. Can't say I've heard anybody else mention it. I wonder if it's one of these notices that goes up in the London Gazette, which not many people read. Or is it one of those that goes up in a council office somewhere?
The plans were on display.
On display? I eventually had to go down to the cellar.
That's the display department.
With a torch.
The lights are probably gone.
So had the stairs.
But you did see the notice, didn't you?
Oh, yes. It was on display in the bottom of a locked filing cabinet stuck in a disused lavatory with a sign outside the door saying, "Beware of the leopard." Ever thought of going into advertising?
To the point that you can do something about it and it will likely improve the treatment. And similarly for all with rare diseases. One of the best arguments and use cases is that the diagnosis for rare diseases can can take years and years and years, and genomic sequencing can rapidly accelerate that.
Now, I had a bit of a problem, and I ended up presenting symptoms of liver failure, kidney failure, numerous other things which really screwed with the doctor's head. I've been tested for diabetes and all sorts of other different bits and pieces, and finally got a genetic test done, just to eliminate everything that they actually know about. And once they'd eliminated everything, they found out that I am perfectly fine and I have chronic fatigue syndrome. Yet they can't do a thing about it because they haven't got a fucking clue about it. So, if it's that good, why have they not made any progress with that?
Radically accelerate it. So in use cases where somebody is ill, we are very front foot and we are very excited about this technology.
The government is taking the responsibility to pay for that, is that correct?
Well, yes, because we have a universal taxpayer-funded health system in the UK.
Now today, it makes you wonder, where all this money's coming from? Because aren't we building 4 new hospitals? Or was it 14? Or was it 40? It was some stupid number that there's not a cat and else chance. We could afford to actually build that many because they couldn't even afford to run the ones they've got now. So it does make you question where they're getting all this money from. But they will get it. But they need your genomic sequence to actually get the money.
And so so absolutely, and in a way, it's a clinical decision.
Yep.
Of course, in consultation with the patient or the patient's guardians, and that in a way, where the baby is ill, the ethics of it are really very straightforward.
It's a straightforward decision. I completely agree.
There's a statistical point on that that's really important to bring out, and that is that while each disease individually may be rare, collectively, this is a very significant percentage. It's about 4% of children that are born with some type of rare variation that presents as some form of disease. Now, the penetrance is different in terms of how extreme the cases are, but the number's about 4%.
Interesting. And so, Jay, as a technology sort of provider, do you think corporations should help untangle what this information means? Like, does that fall on you? Does that fall on biologists? Who has to help us decipher what these 6 billion code means?
Well, it's a collection of all of us, of course. So you have to have great data to start with.
Yep.
And then you have to be able to call the variations accurately. So that responsibility falls on industry and the software providers to produce that raw data. But then there's great research scientists and repositories of data where we're collecting, as GEL has done, great phenotypic information as well as the genotypic information, and then we have that body of knowledge to go learn from. And that's an effort that's going on around the world. GEL has led this, but there's many other programs that are coming along behind that are intending to do the same thing. And as we sequence more and more people, of course, the data becomes easier and easier to analyze because we have better statistical power and we can begin to apply some of the artificial intelligence and deep learning algorithms as well.
We have an army.
I just want to add to that. I'm actually part of it. There's a machine learning study now that we're doing through Chan Zuckerberg, and I'm the ethics person for that, but they're looking at machine learning models. So that would be interesting.
Yeah.
So people are trying to use that more.
Yeah, I think we'll be able to find more and more insights from this data as it's generated. Before we maybe moving on to some of those possibilities, I want to talk about this insurance issue or this payment issue. Does whole genome sequencing for populations only work in single payer systems? Like, how could this create health inequalities if people have to pay for it themselves or private insurance companies have to pay for it? How is all of this potentially poised to disrupt insurance? And whoever wants to jump in.
Well, I wanted. Do you mind if I
go
first? Because we are paying in the case, taxpayers are paying in the UK when somebody is ill, but we're also introducing what we're calling genomic volunteering. But we're also introducing what we're calling genomic volunteering.
So you're paying into the health service, and there's nothing wrong with you. But you want that service there in case of accident and emergency. why are you going to pour more money into it? Not unless they had something else in mind.
Which is that if you want to pay, then we'll ensure that that service is available. Which is that if you want to pay, then we'll ensure that that service is available.
So you get your genomic test done, and you find out there's nothing wrong with you. So what service could you possibly be paying for? Because there's nothing wrong with you. Why do you need anything? Why do they think they're going to be generating money? Because of your genomic sequence, and you're going to need the health service. Are we cottoning on yet?
And the insights from that will go into the same part of the system, the impact of that information on insurance systems, has got to be very carefully regulated. And in a sense, it already is. And I want to draw a parallel which says that the European Union decided a couple of years ago to rule invalid in insurance pricing a specific piece of genetic information, that is your sex.
Now listen to this again. Think about it. Listen to it and think about it. That something has been deemed invalid. Huh? Doesn't count. It doesn't count, and it's legal.
The European Union decided a couple of years ago to rule invalid in insurance pricing a specific piece of genetic information, that is your sex.
So, if you think about this, they have deemed that for insurance purposes, you do not have a sex. Right? So when you go into court to make a claim, you are not a man or a woman. You have no standing. They've literally written you out of the law. You are now what they would class as a dead, empty vessel. No sex, neither man nor woman, in legal terms. So why is there no liability? Because for insurance purposes, you're neither a man nor a woman. So you wouldn't even get a day in court.
So we used to have Sheila's Wheels.
Sheila's Wheels are superstars.
I don't know if any Australians. A brilliant Australian insurance company that only insured women and therefore provided lower, because women are better drivers than men. That is true. And we've just got to come to terms with it. So the premium were lower. But that is taking a very obvious and specific piece of genetic information and using it for insurance purposes, and that is now not lawful in the EU. And so there is absolutely a role for government in deciding what information is and isn't valid in the provision of insurance.
Hence, no liability for a global experiment.
Yeah, I think I'd add to that point by saying, it's going to vary around the world. Single-payer systems are certainly easier to implement. But in the U.S., for example, the All of Us program will be sequencing 1 million people in the next 5 years. So it's another one of these volunteer programs. The government is paying for that as a long-term longitudinal research study. But certainly over time, individual payers in the United States will begin to adopt these technologies as the economics continue to improve and we drive the cost of genome sequencing down to $100 ultimately, which is the goal, and the health outcome benefits become obvious. And so as soon as that equation flips, the health systems will begin paying for it.
Just one thing to add, Sheila's Wheels made me think of this, is that in the United States we have an act, Gina, you're protected in terms of losing your health insurance or your job, legally, at least theoretically, but it's been pretty robust from genetic information that gets out about you, but you're not protected in terms of purchasing long-term disability insurance or long-term care insurance, which more and more middle-class people, as well as, really anyone who can afford in the U.S. purchases, because we have no safety net to take care of us when we're old, except purchasing long-term care or disability insurance, and you can be dropped from that based on genetic information.
That services dwarfs hardware.
So that's a huge justice issue right there that needs to be dealt with as a policy solution.
Stefan, I was going to ask you to sort of maybe talk about your thoughts around genetic discrimination is sort of how this is often talked about. In particular, I've seen it actually with life insurance as well. If you have certain genetic mutations, your premiums go up, which is just wild to me. So, Stefan, I don't know if you have any thoughts about the role of insurance here and stuff.
So I think it goes back to first what is ethical to do, what's the law, because in many countries this is regulated and so on. I think we have to be very careful, because if you think about the concept of insurance, is to try to prevent catastrophic events. And so if you start not insuring people or having different premium and so on, I mean, you just go against the concept of insurance.
Right.
The whole reason we have insurance is that when somebody has a catastrophic event, then everybody pulls together, the funds put together to take care of that. So that's something that we have to be very, very careful that doesn't happen.
Well, I don't think they've been that careful, have they? Because now you actually have something out there that could be more detrimental than the thing it's meant to be getting rid of. And this plays a major part in what's happening.
And I think there'll be some structural changes in the way life insurance works here, because it's based on the idea of pooled risk, and once you sort of begin to decompose that and you get individual risk and you have knowledge of the individual risk, I think that the whole mechanisms need to be thought through again.
Yeah, but it kind of highlights the point that we need more data to support the changing of the equation.
But that could lead, depending on governance, and we have a lot of questions right now about governance this week, right?
Yes.
So depending in the U.S. versus the U.K., I'm very worried about governance. So that and I've looked at this with orphan drug laws too, and there's a bunch of areas where with precision medicine, people could be differentiated into risk groups that could actually put them in economically perilous situations unless we have better governance.
Yeah, I completely agree. One sort of issue around this as well is, for the first half of this panel, I've been trying to focus on the risks so that we can understand all the concerns here. And one risk or concern I have is about who owns this data, the data ownership piece. If this is a baby being sequenced from birth, is it that baby's data? And what consent did they play in that, or is it the parents, the families, the healthcare providers, the government? So maybe, we can go down the line and see how you think about that.
Well, the data of a patient ought ultimately be controlled under the consent of that individual. This is the principle that underpins all data protection in the UK, and indeed is the underpinning concept behind GDPR, which is the European and increasingly global standard.
It should be, but it's highly likely it's not going to be, because there's more money to be made by sharing all that information around. Lots more. Especially when you start getting into the, shall we call it the augmentation? I don't know, say, military-wise?
I think that's incredibly important. Nevertheless, it often isn't in the competence of an individual to be the data processor or the data controller. So in the UK, your GP, your primary care provider, is your data controller for your health data legally.
So essentially, your doctor has control of it.
But conceptually, it's got to be the individual.
Not you.
Or their guardian for a child. And I think that this is an area that's incredibly important to get right as we structure the data architecture into which all of this vast data is flowing, both to ensure the access of the right people at the right time, the interoperability question, which is very live in health systems across the world, but also to ensure that consent is at the heart of it.
Yeah.
Consent is at the heart of it.
Yeah.
Consent is at the heart of it.
Yeah.
Because I think it's a really interesting debate about whether everyone should have their genome sequenced at birth. But implicit in that is that you actually slightly switched the question as you asked the audience. You said, will the majority, as opposed to will all, and it's a massive difference because the gap between this being the norm and not allowing people to opt out, which would be a huge imposition of the state into people's lives.
Didn't bother you too much when everybody was made organ donors?
Yeah, I mean, I believe, and I think our company's position on this is that the individual fundamentally owns their own genome and their data, although it's typically housed somewhere other than on their person or on their computer. But they need to have the right to remove it from some public storage or the cloud or wherever it is housed. They should be ultimately in control of that to a much greater extent, for example, than we are controlling our own social communications and social media data, which is a big problem.
That's very true, yeah. Drew, do you have any thoughts?
Yeah, I mean, I think we've blown it in a lot of the sources of our data, any control, and I think we have an opportunity to not blow it here.
To do it right, yeah.
Yeah.
Cybersecurity and security of data. After a 9-month hack of 5 security departments. Yeah, right.
I agree with panel.
Okay, great.
Patients should load the data. We need help to understand the data.
We need help to understand it. I also think your point, we need to set up infrastructure so that we can actually use it in the right ways and let people opt in and opt out at different times.
Skip forward a bit and then comments about risk benefits. At the moment, it's too risky.
Sense of it.
So what would you be looking to be in place before it was made the norm and the expectation?
Norm versus a requirement, I love that, where there's always opt-out. I'd say I don't know forever if there should be opt-out. I don't like people opting out of vaccines. I don't like people opting out of vaccines.
So what about a vaccine that could quite possibly make you dependent upon your health service for the entirety of the rest of your life?
So there might be a point in public health where the genome is so effective and powerful that we really want to discourage opt-out, except for very strong religious reasons. So I'm not even saying we have to have opt-out forever, but we all seem to agree right now we'd want opt-out.
And newborn screening in the U.S. is not really opt-out either.
Yeah, well, and that's good. So I believe I'm a professor in a school of public health. So I think that, but the only thing I'm saying now, I can't say where the science needs to be for it to be productive yet, because I think there's a lot of promise already in newborn screening. I'm more concerned with the counseling part. So it could be very soon that we could have, but the thing is, at least in the US, we're not investing. We could do so much to save children's lives right now, many more children's lives with the social determinants of health that we're not addressing. That doesn't mean not to do this, but I'm saying that I want to see a health apparatus for people.
Well,
go with it.
I think it's important to talk about whether this should be the norm or required. So some of the work that the Biotechnology Council council here at the Forum is doing is around this idea that as we move forward to get access to the best health or the best treatments, we need to know about your molecular information. But for that molecular information to have value, people like you have had to previously contribute that data so that we could develop, drugs or therapeutics around it. So one of the things that we're talking about, is there a moral obligation to contribute your data so we can build these data sets that could improve human health? And how do we think about that? Also putting in, cultural expectations and stuff like that. And I'm looking to you for this one.
Well, we live in a free society, and that means people are free to be unhealthy, even if we don't think that's a good idea. And I think that setting norms, setting expectations, giving people the capacity to make decisions correctly.
Antisocial distancing. Your bioelectric field can extend up to around 10 feet around you. Wear a muzzle, even though they don't stop viruses getting through. It's even in Fauci's emails. You know, it's undeniable. Anybody still carrying this on is stupid. Oh, and, you know, how's about common sense? No, you don't like that, do you? Because that means people are thinking for themselves, not taking somebody else's guidance or advice, like your specialists. Yeah, is that the same people who are saying this vaccine's so brilliant that it's causing a lot of problems on a scale bigger than the problem that it was meant to fix?
And using behavioural concepts to help people to get to what we think is the right, what the experts think is the right answer.
There he is, hiding behind the medics again. He loves hiding behind other people.
That is one thing, but going further than that and requiring is a whole different, a much more problematic step.
Mm-hmm. So you didn't try it yourselves, you've actually tried to get big corporations to do it for you. So you can say, well, we didn't bring all this in. No, it's the companies that brought it in. But the customers, for a good portion of them, don't want it.
And undermines the whole principle of consent, which should be at the heart of this. There's a practical question, which is how far to go in offering. How far to go in offering. How far to go in offering.
We estimate we can sell up to 80% of an individual's visual field before inducing seizure.
You know, you can get to a very large proportion of the population by changing norms and expectations, like the fact that the heel prick test and the blood tests in the UK is totally standard, but is very important. I think there's another really exciting prospect here, which is around predictive prevention.
Yep.
The ability to change public health from its 20th century approach, which is essentially based on the need for contagious disease, tackling contagious diseases, where the whole population is treated the same, and changing that approach to a more targeted approach dependent on people's need, which should be the basis of public health for non-contagious diseases. And this is incredibly exciting. But there's no large organization that would try to get messages and actions over to individuals that would treat them all the same.
Mm-hmm. He's not even clammed up. He's alone.
But somehow the default in public health, partly because of the history, has been treat the population as if they're all the same, but they're not. And we have this great opportunity to reshape public health to be both more effective and less nanny state, so that you're intervening more strongly with the people who need it and leaving people who don't need it to be more free.
Loyalty Division is reporting profits up 28%. Finale.
We're opening 5 new loyalty centers this month.
I completely agree. I think it actually offers the chance to make, to empower the patient. And, you know, I work in the precision medicine field where we are trying to move away from one-size-cuts-all treatment to more precise treatments. But this actually has the ability to even become more personal and truly put the patient at the center of their own health care. if done right, I think is the question. So we've been talking about this as if it's something in the future, and it's happening now.
Where the future is being made today.
So Geisinger has sort of integrated the ability for their people in their health system to get sequenced. There's this Baby Seq project that is federally funded in the US to sequence babies from birth. So this is happening.
All of this implies we win the contest.
Indeed it does.
And for me, as a scientist, I'm actually encouraged. I have questions about the who, the what, the where, the why, and the how. But Jay, to something you said, this has the opportunity to be that dream longitudinal data set that lets us understand, how biology works, how disease works, and help us kind of, move towards a better health and healthcare system. So I'm encouraged by it. But I think, again, there's a lot more that needs to be resolved. So tomorrow is actually my birthday. And so for my birthday, I'm going to ask you guys one question. We'll just go down the row, and then I'm going to turn it a question to the audience and then let you guys ask questions. After everything that we just discussed, Stefan, we'll start with you. Should we start sequencing babies on my birthday tomorrow?
I don't think so. I think it's too early. I don't think so. I think it's too early. I don't think so. I think it's too early.
Okay, Jody?
No.
Okay, Jody?
No.
Okay, Jody?
No.
So we should intellectually commit to do that, but implement it with great discipline, great thought. All the topics that we've brought up here, I think, on this panel about making sure there's adequate counseling, making sure the health economics are correct. But it takes years to put these kinds of projects in place. And so I think we need to start now, because I think the vast majority of people in this room and probably outside this room believe it's inevitable. So let's start thinking about how we get there and get there responsibly, productively, and sort of flip the health paradigm so we can begin to save these babies, number one. And really, to the preventative point, I think, there's an awful lot of talk about preventative medicine, but you don't know what you're trying to prevent unless you have some indication of what the risk profile of patients are. This is a great way to start really, really important prevention programs.
I agree with that, and I'd say let's start with where we know that action's needed. So if we start with
clinical utility,
start with ill babies, and work out from there.
Yes.
But make sure that we do this with the trust of the citizens who we serve.
Awesome.
The trust of the citizens who we serve.
Awesome.
The trust of the citizens who we serve.
Awesome. Okay, and so for the audience, the birthday present I would like from you is not if we should do it tomorrow, but do you think we should sequence babies from birth? Raise your hand.
I mean, it's nothing less than a war for control of the future.